All right, so power in AC circuit example 3, right? So we are going to go over the problem. So an EMF whose instantaneous value is given as this, right? So in this example, they've given the quantities, the sinusoidal quantities as a function of time, right? It's a function of time. So there's a voltage applied to inductive circuit, right? And the current is this, right? I want us to determine the frequency of the EMF, right? And then if we've been following what we've been doing, this is straightforward, right? But let's go right. Let's see. Okay, let's see. Okay, so now we're talking about the first part, right? A. So we know that when it comes to sinusoidal what do you call it? Sinusoidal functions, AC quantities. The general formula is we have the peak value, right? So let's say the voltage, right? Okay, because we're talking about voltage. So voltage. So we have voltage, peak value. This is the general formula. General, yeah, general representation, general form. So basically, we have the peak value, right? And we have the sine. So you have the peak value. You have the peak value. You have the sine, right? And then in it we have this could be an integer, right? Depending on the frequency. And then we have just W, and then we have T, and we have plus or minus the phase shift, right? And looking at the voltage, the EMF that we're given, right? It has this was having, right? And it wants us to find the frequency. Meaning that the only place that we can find the frequency is this side, right? Okay, so this means that this whole thing here, this 314 T is equal to 2 pi f t. Right, so when we take the t's out, that's what we have. So we can find the frequency. This means that the frequency is equal to 314 on 2 pi. Right, so that gives us the frequency. So let's see what we are getting for that. Yeah, so whatever example, whatever problem that you have, it's very valuable that you have the basics. When you have the basics, whatever the problem is, you find a way to go around it and then get to solve it, right? So here is the case that we know the basic form, right? And we are using that just to find what we have here. So let's see, that's 3 and 4 on 2 pi, right? Okay, so that gives us a frequency of let's do 4 dB, 49.9747 and hertz, right? That's the unit. Most of the time these ones are rounded up because there's the frequency, so kind of like 50 hertz, right? The next thing for us to find is the resistance and the inductance, right? So let's see. If you find resistance and inductance, you have to find both of them. By looking at the circuit, you're seeing that it's inductive, and asking us to find, and because it's inductive, there will be some sort of resistance there as well. So basically, what we are doing is we are dealing with a circuit of this sort that we have an inductor, and then we have a resistor, right? So we have these two. This is what we are considering, right? Okay. And looking at that, let's see what values were we given. We're only given this and this, right? So we know these two, this R and L, can be found within some other thing. This L can be found within this XL, right? And we can find these two from Z, right? And we've been given V and I, so meaning we can use, because of how the circuit is, we can't use V is equal to IR, right? Because the circuit has resistor and inductor. So what we'll be using will be V is equal to IZ, right? And we need Z to find these two, right? So let's see. So that means that Z is equal to V on I, right? So let's see. And then let's see. One other thing is that because these ones are given as a function of time, and we're trying to find the Z, we have to use the RMS value, right? So that will mean that we'll need V RMS divided by I RMS. What we've been given the sinusoidal ones, and we know that because they are sinusoidal functions, we are trying to find the RMS value. It's just the peak value. So in this case, if it's for the voltage, we take the peak value like this one, like this, divided by root 2, right? So the same thing for both. So that will mean that I will need voltage on root 2, and then I divide it by the current on root 2, right? Yeah. So the voltage is 2A3, right? And the current was given. The peak value for the current is 5.66, right? So that gives us a Z, or an impedance of 50, right? So impedance is 50, and what's the unit? Because it's impedance, that's ohms, right? Okay. Now that we have this, let's see. That means that we should be able to find, the question wants us to find, what do you call it, the resistance and the inductance, right? And we know these are components of the impedance. So let's see. Let's go over this one more time. Okay. So that will mean we have XL here, right? They're having this too, so mean that the impedance will be about here, right? Impedance will be here, right? So we can find this when we have the kind of like the phase shift, right? So how do we get a phase shift? We've been given the voltage and the current, right? If we're to be, that means that the voltage and current are not 90 degrees to each other, right? So we use their phase difference to check. And how do we check that? This one has its own phase shift, this one has its own phase angle, right? So we do that. And because, let's go over this, well, we said that if it's purely inductive, this is how it will be. For purely inductive, you have a minute. Oh. For purely inductive, we have the current here, and then the current here, and then the, what's the name, the voltage here. But because it's a combination of the inductor and the resistor, right? That would mean that they are not 90 to each other. But looking at how they are, it's something of this way. We have the voltage about here because the phase angle is a plus, and you have the current about here, right? And so we just check the phase difference, right? So the phase difference will be equal to, let's see, that's looking at it because it's a inductor, what do you call it, inductor current, inductor resistor. That will mean that the voltage will be here, the one up here, the one leading, and the current will be here, right? So to do that, we subtract the phase, to find the phase difference, this from this, right? Check the phase difference. So let's see. So that for the voltage is what is it? Pi on 4, right? So the phase difference is basically equal to pi on 4 minus, right? For that of the current is what already has its own minus because it's lagging. That's another minus pi on 6, right? Minus pi 6, right? So let's see. Okay, so that's pi is 180, so 184 minus 180 on 6, right? There's a minus, and this gives us what, 75 degrees. That's a phase difference, right? And now that we have that, we'll be able to find the resistance because the resistance is a part of the inductance, right? So let's see. That means that R is equal to Z cos 75 degrees, right? So let's see. We have Z to be 50, yeah, so that's 50 cos 75. Because you are using degrees, make sure your unit here is in degrees. So you see radians, degrees, radians, right? So make sure it's in degrees. All right. So that gives us 12.940. Okay. Let's do 4dp. So that's 12.940. Let's do about 9, right? Ohms, right? And now that we have this, we can find what do you call it? We know that in order for us to find the inductance, we need XL, which is inductive reactance, right? So we need XL. We know XL is equal to Z sine 75, right? To change it to sine, and that gives us 48.2963 ohms. Always do the number of decimal places based on what is required, but here I'm doing 4dp, right? Okay, so I have both now. What else is being asked? So we are done with the B part. So we are done with this and this, right? Oh, we are not done. We just found the capacitive what do you call it? Inductive reactance. We will now have to find the reactance, inductance itself, right? So that will mean that we have a XL being equal to 2 pi F L. So that will mean that L is equal to this XL. L is equal to XL on 2 pi F, right? So let's see. We have our XL to be this. So that's 48.2963 on what? 2 pi, and the frequency is 50, right? Approximately 50. So that gives us inductance of 0.1537, and inductance is in what? Henry, right? So if we want to do this, introduce a prefix. So we move, let's see, 1, 2, 3, and that gives us 153.7 millihenry, right? Yeah, millihenry. Yeah. So you can choose to keep the henry just like that. The same. All right. Yeah. Okay. So what we have to do is to find do the C part. It's the power absorbed, right? So we know that power absorbed here, because it just said power, means that we're talking about active power, real power, true power, right? Now to find that, we know power is equal to I²R, or yeah, I²R, right? So let's see. Yeah, we have the current, we have the resistance, right? Okay, let's see. Or another way to do it would be to use the voltage, the RMS value of the voltage current. So this basically becomes this right here becomes the RMS values from what we have, right? And then we do cos theta, right? Any of them will work. So let's do it one by one. Let's do the I²R. What do we have for the I? I is, let's see. Okay, I is 5.6. So you are doing the RMS value. So I² times R. I is 5.66 on root 2. Why? Because you are using RMS values. The other one too should be on root 2, right? Root 2. Okay. What was the R? What do we get for the R? The R was, let's see. Okay, that's 12. R is not a sinusoidal quantity, so just 12.94. So at the moment, that's what we are using. We are using this one to see what we get, right? 12.9409, right? And that gives us 207. Let's see. That gives us 207.2847 versus per watts, right? The unit very important. Watts. Right? So now let's try this one, right? Let's see. We get the same thing. So the voltage RMS value, right? That's 283, right? Let's see. Is it 283? Yeah, 283. So we want the, what do you call it? The RMS value. So on root 2, that's for the voltage, the current, right? On root 2, so another sinusoidal quantity. And here we have 283, and here is the current is 5.66, right? Okay, now we have that. Multiply by cos. The phase difference is 75, right? Yeah, so clearly it gives us the same answer again. So whichever method I use, depending on what's available to you, use them. The one you're familiar with, and then you find 207.285 or 56, right? And also what? So you see, both of them work. This works, this works. Is there anything we have to solve? Well, that's the last part. So C solved as well. Yeah, so C solved as well. Alright, so that's it.